In our last video, we talked about solving partial fractions. We have talked about solving non-repeated linear factors, and we also talked about solving non-repeated non-linear factors. So what happens when we have repeated factors and which could be repeated linear, and also it could be repeated non-linear. So take for instance, what do we mean by repeated factors? So if you have a format of ax plus b raised to the power n now as a factor on the denominator, definitely we know that ax plus b is linear. However, there is a power here, a power of n, which shows that it is repeated. So for example, we have 2x plus 3 into x squared, right? And x plus 3 all squared. Alright, so we have two factors. We have x plus 3 and we also have x. Okay, x is linear and x plus 3 also is linear. However, they are repeating 2 times. Okay, so that means we are going to have 4 plus and finally the fourth one. So the first one will be x, okay, and the next second one will be x squared because it's repeated twice. The next will be x plus 3 and the next will be x plus 3 whole squared. Now, since they are linear factors and everything that the denominator is x is power 1, x is power 1, x is power 1, and x is power 1, as we have seen, okay, definitely at the numerator rather, it will just be a, b, c, and d. Now, let's explain again with another example. Given that we have x squared plus 3x minus 5 divided by 2x minus 7 and x squared plus 3 raised to power 3. Now, how many factors can we see here? We can see two factors. One is 2x minus 7, which is linear, and the second is x squared plus 3, which is non-linear. However, the x squared plus 3 is repeated 3 times. Okay, is repeated 3 times, so we will have 4 factors in total. 1, 2, 3, and 4. Okay, the first one, which is linear, x minus 2x minus 7. The second one will be x squared plus 3 raised to power 1, right? And this one will be x squared plus 3 raised to power 2. And x squared plus 3 raised to power 3. Okay, the number here 3 must tally with the power here. So now this is linear. Okay, so that means we will have just a, and this is non-linear, like we have done before in non-repeated non-linear factors at the denominator. So we'll be having bx plus c, and here is still non-linear, so also we'll be having dx plus e, and this is still also linear starting with x squared, so we'll have finally fx plus g. Okay, now we will try as much as possible to solve the problem. And now let's start with an example question. These two are just to show that this is how the factors has been splitted. The partial fractions have been assigned. Okay, so now let's solve something. Given that we are given 3x minus 2 divided by x plus 1 squared and x minus 3 squared. Now we can see that we have two factors. We have a linear factor and also a linear factor, of which both of them are appearing twice. Okay, so that means we are having a repeated twice, so we are going to have 4 factors in total plus 4. Okay, so that means the first one will be x plus 1, raised to the power 1. The next will be x plus 1 all squared. The next will be x minus 3 raised to the power 1. And the next will be x minus 3 all squared. Now we are dealing with repeated linear factors. Okay. Now since they are linear, we will have A, we will have B, we will have C, and we will have D. Alright. So to solve that further now, we just have to find the LCM. So we can remove the powers of 1 here, which might not be needed afterwards. Now let's find the LCM. So we have 3x minus 2, x plus 1 squared, and x minus 3 squared. Now the LCM of the right hand side is x plus 1 squared and x minus 3 squared. Now let's not try and make mistakes. So the solution at the numerator now will be A, okay, into x plus 1 and x minus 3 squared plus B into x minus 3 squared plus C into x minus 3 and x plus 1 squared and plus D into x plus 1, okay, 1 squared. Okay, now we took LCM. So in that case, we can now cancel out the denominator since they are equal. So we'll be left with 3x minus 2 is equivalent to A, so x plus 1 into x minus 3 squared plus B into x minus 3 squared plus C into x minus 3 into x plus 1 squared and plus D into x plus 1 squared. Now, question, how do we solve A? How do we solve B? And also, how do we solve C and D? Now, people might say cover-up method, will it work? Sure, cover-up method will work, but we might not be able to evaluate everything using cover-up method unless we are very tactical about it. Okay, so most of the times we might end up using comparing coefficients. Okay, might end up using comparing coefficients method. So we open the brackets individually and then we will have simultaneous equations to solve them. Now, however, we can apply cover-up method to make a x plus 1 x minus 3 equals to 0. We can say x is equals to minus 1 and x is equals to 3. This will make it 0, and here we can put x to be equals to what? To 3 to make b 0, and here we can put x is equals to 3 and x is equals to minus 1 to make c 0, and here we can just put x is equals to minus 1 to make d 0. So let's apply cover-up method. Apply cover-up method. Now let us put x to be minus 1. Okay, so when we put x to be minus 1, we have that 3 into minus 1, that means we are substituting x to be minus 1 into this equation, minus 2 is equals to a into minus 1 plus 1 minus 1 minus 3 squared plus b into minus 1 minus 3 squared plus c into minus 1 minus 3 minus 1 plus 1 squared plus d into minus 1 plus 1 squared. Now we can say minus 1 plus 1, we can say minus 1 plus 1, and we can say minus 1 plus 1. Minus 1 plus 1 is 0, so it will make this 0, it will make this also 0, and likewise this. So we are left with 3 into minus 1 minus 2 is equal to this, b into minus 1 minus 3 squared. Now, so thereafter, we can simplify to get our b. So we have minus 3 minus 2 is equals to b into minus 4 squared. Minus 3 minus 2 is minus 5, and minus 4 squared is 16, so we have 16b. So at the end we'll have that b is equals to minus 5 divided by 16. Good. Now let's apply cover up method again, so we can put x to be equal to 3. Okay, so since the only two common factors between all things that we have here is x is equals to 1 minus 1 and x is equals to 3. So let's put x is equals to 3 in this equation. Okay, so that means we'll have 3 into 3 minus 2 is equals to a into 3 plus 1, and 3 minus 3 squared plus b into 3 minus 3 squared plus c into 3 minus 3 into 3 plus 1 squared plus d into 3 plus 1 whole squared. Okay, now we can see this will make it 0, this will make it 0, and this likewise will make it 0. So that means this is 0, this is 0, and this is 0. So we'll be left with 3 into 3 minus 2 is equal to d into 3 plus 1 squared. So 3 multiplied by 3 is 9 minus 2 is equals to d into 4 squared. So 7 is equal to 16d because 4 squared is 16. And then we'll have our d to be equals to 7 over 16. Now, after establishing that, how do we now solve for our a and c? Since the only two factors that can turn other values to 0 are just x is equals to minus 1 and x is equals to 3. Now to go ahead and solve this, we just have to be flexible. We can apply use some values of x, maybe assume x is equals to 0 or x is equals to 1 to have two simultaneous equation. Or we just go ahead and we open up the brackets and use our comparing coefficients. So let's rewrite what we have here. Okay, let's rewrite what we have here. So that means we'll have 3x minus 2 is equals to a into x plus 1 x minus 3 squared plus b into x minus 3 squared plus c into x minus 3 and x plus 1 squared plus d into x plus 1 squared. Now let's open the brackets. So we have 3x minus 2 is equal to, okay, the sixth term we'll be using here now. We want to apply two rules, and write it here, is that a plus b all squared, and we'll have a minus b all squared. So this will be first a squared plus 2ab plus b squared, and a squared minus 2ab plus b squared. Now these are just algebraic, so that we will have limited steps and limited lines of problems. So 3x minus 2 equals to a into x plus 1. Now we open x minus 3 squared, we'll have an x squared minus 2ab, that's 2 multiplied by 3 multiplied by x because we're applying this. So that will give us x squared minus 6x plus 9 plus b into x squared minus 6x plus 9 plus c into x minus 3 into x squared plus 2x plus 1 plus d into x squared plus 2x plus 1. Now, with respect to that, we cannot open further. So we have 3x minus 2 is equivalent to a let's open with x. Okay, so if you open with x, we have x into x squared minus 6x plus 9 plus 1 into x squared minus 6x plus 9 plus b into x squared minus 6x plus 9. Try not to skip steps. Plus c into x squared plus 2x plus 1 minus 3 into x squared plus 2x plus 1 plus d into x squared plus 2x plus 1. Now, having done that, we have about 3x minus 2 is equals to a into x raised to power 3. That means we're opening this first. X raised to power 3 minus 6x squared plus 9x. And after this, plus x squared minus 6x plus 9. Okay, then we can move ahead with our b into x squared minus 6x plus 9. Then our c plus c, I'm going to open this here, so that will give us x raised to power 3 plus 2x squared plus x. Then we can open minus 3x squared minus 6x minus 3 plus, after we have d into x squared plus 2x plus 1. Now we're almost done. So 3x minus 2 is equals to a. We take the x squared together and the x together, so that we'll have 1. So we have x squared, we have minus 6x and plus 6x squared, so that will give us minus 5x squared. We have 9 and we have minus 6, and 9 minus 6 will give us 3x, and then we have 9, okay, plus 9 plus b into x squared minus 6x plus 9, and plus c, we have x raised to power 3, we have 2x squared, and we have minus 3x squared. So 2x squared and minus 3x squared will have minus 1x squared, and x plus x and minus 6x will have minus 5x, and minus 3 plus d into x squared plus 2x plus 1. Now, having done that, now we can now open up our brackets with whatever we have. So 3x minus 2 is equals to ax squared, x raised to power 3, okay, minus 5a x squared plus 3ax plus 9a plus, now we can just arrange them in order, plus bx squared minus 6bx plus 9b, and plus cx raised to power 3 minus cx squared. Okay, we are here now. Okay, minus 5cx and minus 3c plus, let's solve for our d now. So we have dx squared plus dx squared plus 2x, that's plus 2dx plus d. Now we can now come it up and say 3x squared minus 2 is equals to a plus c x raised to power 3 plus everything here minus a minus 5a plus b minus c plus d minus 5a plus b minus c plus d all into x squared, and the same thing for our x. So we have minus 3a minus 6b minus 5 and plus 2d, 3a minus 6b minus 5c, and plus 2dx, and finally our constant term that will give us plus 9a plus 9b minus 3c plus d. Now we will now have to compare coefficients. Okay, compare coefficients. Now we will compare for x raised to power 3, x squared, x, and the constant term. Okay, now for x raised to power 3 we have a plus c. For x squared we have minus 5a plus b minus c plus d. For the x term we have 3a minus 6b minus 5c plus 2d. And for the constant term we have 9a plus 9b minus 3c plus d. Now the coefficient on the left hand side, we know that our answer is 3x minus 2, and we can rewrite this as 0 x raised to power 3 plus 0x squared, okay, plus 3x minus 2. So with respect to that, we know that our coefficient for x raised to power 3 is 0, 0, and 3, and minus 2. Okay, so I can just put this here. So this will be our equation 1, equation 2, equation 3, and equation 4. Now, previously, we have solved for B, and D. Okay, this is our B and this is our D. Now, we can now go ahead and solve for A and C. So that means I'm saying that if my B is equals to minus 5 over 16 and my D is equals to 7 over 16. Now, because of time, I will leave you guys to solve others. That means A and C. So that means I'll just write the final answer. Solving simultaneously, our A equals to 1 over 32 and our C is equals to minus 1 over 32. Okay, so with respect to this now, we will now go back like we have done before. We will now go back to the beginning where we splitted our terms. Okay, this was where we are. Okay, then we now substitute our values for A, B, C, and D. Now let's substitute our values there. So we're writing, we have 3x minus 2 as the original question, x plus 1 squared, x minus 3 squared, to be equals to A by x plus 1 plus B by x plus 1 squared plus C divided by x minus 3 plus D by x minus 3 whole squared. Now let's substitute our value for A. A is 1 over 32 over x plus 1 plus B minus 5 over 16 over x plus 1 squared plus C minus 1 over 32 over x minus 3 plus D 7 over 16 divided by x minus 3 squared. Now simplifying further, we have it to be 1 over 32 into x plus 1 minus B plus must multiply minus out, so give us minus. So we have it minus 5 over 16 into x plus 1 squared. And same thing happens here. Positive multiplied with negative. So it was negative, so it will be 1 over 32 into x minus 3 plus 7 over 16 into x minus 3 squared. Now, here is what we have. So this 3x minus 2, I got the question, x plus 1 squared and x minus 3 squared. This is the solution to the problem. Okay, so we'll pick one more example on this. One more example. partial fraction, and repeated roots. Now lesson number 2, we are given to resolve into partial fractions of x squared plus 3x plus 1, and we have x squared into x plus 3 squared. Okay, into x plus 3 squared. So to resolve this, are they linear? Yes. X plus 3 is linear. Yes. How many times are they repeated? They are both repeated 2 times. Okay. So with respect to that, we'll have what? By x is divided by x squared. Okay. Plus x plus 3 and squared. Now let's make no mistake. So this will be A, B, C, and D. Now don't take this as a non-linear. It's advisable not to take this as a non-linear factor because x was repeated twice. Okay, that is why we have this. Okay, so now we can now go ahead and solve. Okay, let's take the LCM of the right hand side. So we have x squared plus 3x plus 1 divided by x squared into x plus 3 squared, because the LCM on this thing will be x squared into x plus 3 squared. So we have it to be A into x plus 3 squared plus B into x plus 3 squared plus C into x squared, okay, plus C into x squared into x plus 3 and plus D into x squared. Let's close the bracket there. Alright, so since the denominator are equal, like we usually do, we now focus on the numerator plus 1. So let's just rewrite it. We can apply cover-up method for a start to get some values before we go into comparing coefficients. Plus C into x squared and x plus 3 plus D into x squared. Now after that is done, then look at this value. For this variable, for this whole thing to be 0, we have our x to be 0 and our x also to be minus 3. Okay, and for all these things to be 0, we have that x is equals to minus 3. For all these to be 0, we have that x is equals to 0 and x is equals to what? Minus 3 also. And for all these to be 0, we have that our x to be equals to 0. So let's put x to be equals to 0. So from putting x is equals to 0, we have that this will give us 0 squared plus 3 into 0 plus 1 is equals to a into 0 into 0 plus 3 squared plus b into 0 plus 3 squared plus c into 0 squared into 0 plus 3 plus d into 0 squared. Now 0 multiplying by 0 will give us 0, this one is 0, and this also will give us 0. So we are left with 1 here, and here give us b into 3 squared because 0 plus 3 is 3. So 1 is equals to 9b. So now I'm saying b is equals to 1 over 9. So now let us put x to be equals to 3. If from this same equation, wherever we see x, we substitute 3. Okay, so that means 3 squared plus 3 into 3 plus 1 is equal to a into 3 into 3 plus 3 squared plus b into 3 plus 3 whole squared plus c into 3 squared into 3. Oh, sorry, we are putting x to be equals to minus 3. 3. Thank you. Minus 3, minus 3, minus 3, minus 3, plus 3, plus d into minus 3 squared. Okay, now we see minus 3 plus 3 returns 0, minus 3 plus 3 returns 0, minus 3 plus 3 returns 0. So this will equate to 0. So we are left with 3 squared is 9, 3 times 3 is 9, plus 1 is equal to, now we are left with this, right? So that means d into minus 3 squared is also 9. So 9 plus 9 plus 1. Okay, yes, is minus 3 squared, please. Okay, so minus 3 squared is 9. 3 multiplied by minus 3 will give us minus 9. Okay, so it's 9 minus 9 plus 1. We'll have 1 is equals to 90. So that means also our d is the same thing as 1 over 9. Now, after we have now solved, well, this is usually how it is usually we first apply our cover up method, and thereafter we apply comparing coefficients. Okay, so okay, let me teach you a technique. Instead of opening up the brackets, okay, instead of opening up the brackets, we can use another method to get our values for A and also our values for C. This is possible. Now, since we have used x is equals to 0, and we have used x is equals to minus 3. Now, all we just have to do is to put in values. Okay, to find A and C, we can take any value except from x is equals to 0 and x is equals to minus 3, since we have already made use of them. So we can see that let's assume x is equals to minus 1 and x is equals to 1. Okay, so still from this same equation, okay, still from the same equation, we say we want to substitute x is equals to 1 and also x is equals to minus 1, so that it's just a medium to bypass the comparing coefficients method, which is very quite efficient. Okay, and to do that, so let's put x to be equals to minus 1. So we will have minus 1 squared plus 3 into minus 1 plus 1 is equals to a into minus 1 into minus 1 plus 3 squared. I am following this order here. Okay, plus b into minus 1 plus 3 squared. Okay, plus c into minus 1 squared and minus 1 plus 3 and d into minus 1 squared. So when we solve this, we have 1 minus 3 plus 1 is equals to a to minus 1. Minus 1 plus 3 is minus is 2. Okay, and 2 squared is 1 is 4 plus b minus 1 plus 3 is 2 squared and 2 squared is 4. Okay, plus c into minus 1 plus 3 is 2 plus d into minus 1 squared, that's 1. So 1 minus 3 minus 1, okay, will give us minus 1, will be equals to minus 4a plus 4b plus 2c, and minus 1 squared is plus 1 and plus d. So we can call this equation 1. So instead of putting minus 1 as we have done before, and let's put x to be equals to 1. Now you might decide to use minus 2 and also decide to use plus 2, okay, as the case may be. So let's put x is equals to 1. So 1 squared plus 3 into 1 plus 1 is equals to a into 1 plus 3 squared plus b into 1 plus 3 squared plus c into 1 squared 1 plus 3 and plus d into 1 squared. This gives us 1 plus 3 plus 1 is equals to a into 1. 1 plus 3 is 4 and 4 squared is 16 plus b into 1 plus 3, that's 4, and 4 squared also is 16. So c into 1 into 4 plus d into 1. Now this will give us 1 plus 3 plus 1 will give us 5. And this will give 16a plus 16b plus 4a plus 4c rather plus d. Okay, now we can call this equation 2. Now let's recall our values of b and our values for d. Now b, as we have calculated before, is 1 over 9 and d also is 1 over 9. So b is 1 over 9 and d is 1 over 9. So we will now substitute them values for a and b here. And we substitute for b and d. And we substitute values for b and d there. So from equation 1, okay, we can see that our equation is minus 1 is equals to minus 4a plus 4b plus 2c plus d minus 4a plus 4b plus 2c plus d. And let's substitute our values for b and d. So minus 1 is equals to minus 4a plus 4 into 1 over 9 plus 2c plus 1 over 9. And if we now further solve this, okay, we will have that minus 7 is equals to 9c minus 18a. Okay, and we can call this equation 3. And also from equation 2, okay, we can see that we have this equation here. So we can rewrite it. 5 is equals to 16a, 16b is 4c plus d. Now we substitute our values for b and d. So 5 is equals to 16a plus 16 into 1 over 9 plus 4c plus 1 over 9. Now solving this thereafter will give us 7 is equals to 36, or let me write it as 7 is equals to 9c plus 36a. We can call this equation 4. Now we can now solve equation 3 and 4, okay, simultaneously. If you have a calculator, you just plug it in. And when you plug it in, we'll have that our a is equals to 7 over 27 and our b is equals to, and our c, sorry, is equals to minus 7 over 27. So in conclusion, our a is 7 over 27, our b is 1 over 9, our c is minus 7 over 27, and our d is also 1 over 9. So once we have this, as usual, then we go back to the beginning of the question, okay, and when we go back to the beginning of question, then we finalize it and we substitute our values for a and b and c and d. So we have ax squared, which is the question, plus 3x plus 1 divided by x squared into x plus 3 whole squared is equals to a over x plus b over x squared plus c over x plus 3 plus d over x plus 3 squared. Okay, so now we just have to substitute our value. A is 7 over 27 over x plus b, which is 1 over 9 over x squared, plus c, that's minus 7 over 27 over x plus 3, and then plus d, that's 1 over 9 over x plus 3 squared. Now when we substitute our value, we have 7 over 27 into x, 7 over 27x plus 1 over 9 x squared minus 7 over 27 into x plus 3 plus 1 over 9 into x plus 3 squared. And this is the solution of the partial fractions. Alright, so we have now been able to look at repeated factors in the linear formats, and we can also apply the same principles when we have repeated factors in the non-linear formats. So questions might pop up in any format, okay? And the final thing we'll be looking at now will be the improper fractions. Okay, improper fractions occur when we wish to resolve into partial fractions in such a way that the degree of the numerator um, may be equal or higher than the degree of the denominator. So in that case, we will first have to use long division method to divide the numerator by the denominator, okay, before we resolve into partial fraction. And this will take us back into polynomial divisions of polynomial, okay. And if you have not checked out the video on polynomials, kindly do so. It's very important so that you will not get lost in the process, okay, because we will have to look at division of polynomials first, and we will now incorporate it with partial fractions. So see you in the next video.